I will address the use of the neutron probe as a tool for cultural heritage. Is a very rapidly growing area of research, which is nowadays applied all over the world in different facilities. I will show you in a moment, to the investigation of artifacts of archaeological significance. A brief outline on the importance of the materials, because this is the result of a long basic research, which after many, many years has now proved to be useful in this in the investigation of cultural heritage. And then I will briefly introduce you to Neutron, a beautiful tool which has to be used with great care because it's very expensive, but it can solve and give answer to questions of interest for the cultural heritage community when other tools are not useful enough. Then I'll give you some example. In particular, I will show you some, given the time left. I don't want to bother you with a lot of examples, but I've chosen some examples which are on the new imaging neutron techniques, which are under exploitation in these years. And in fact, the Italians, the Research Council has just founded an international project which will be led by Tor Vergata, Milano Bicocca, and the British colleagues to design and develop an instrument devoted to the investigation of cultural heritage, and that in these days is very good since the lack of money in research. And I will give you this example because this is a sort of developing of a tomography, like we do for body, to investigate the interior of materials. So materials are really in an everyday, typical day in any town in the world is very important because it is inside any part of this, or anything you watch. And of course, there are many scientific tools which are used to investigate the materials. And in the last, I would say, 15 years, more or less, depending on the techniques, we are now moving down to 10 to the minus 7 to 10 to the minus 8, which is a magic measure of distance where we have realized that we need specific tools to investigate the material. Why we need to investigate the material? Because we have discovered that scientists have discovered that material at its nanoscale has different properties, completely different from what the materials have at normal distances. And these different properties can allow us to design and develop materials tailored to our needs. So why neutrons? Well, neutrons are, in a way, a perfect tool. This was discovered by Schall and Brockhaus late 60s. Neutron, of course, has been discovered much before that. But they discovered that they can, as they said in the Nobel Prize in 1994, they can tell us where atoms are, and that is also light can tell us where atoms are, but it can also tell us what atoms do. And this is specific on neutrons. Not any other probe can do both. So where atoms are means measuring the position of atoms. What atoms do means measuring the movement of atoms. A very simple example is a football player which can transfer momentum and energy to a ball exactly in the same way neutron can do with atoms. Okay? Light can only transmit energy, no momentum, because the momentum of light is zero, essentially. So a simple way of telling you, I'm sure you are familiar, most of you, with that, but I just show you some example of what how a neutron can be considered as a particle and as a wave. You are all familiar with a wave, a sound wave or electromagnetic wave, and you know this is the only expression I will use all over the talk, but I need that for what I'm going to say in a moment. The wavelength, lambda, is just a measure, remind you, the distance between two peaks or two holes. And so what we are going to do with the neutron is essentially what we are going to do with light. If you imagine light going through a little slit and producing peaks or minimum, and then having this wave interfering, well, the same thing we are doing with neutrons. So you have a maximum of interference when the two waves are in phase, as we say, or you have a destructive interference when the two peaks are out of phase. So essentially, neutron is doing that with matter. So you have the atoms were displaced at regular distances, and essentially the distance between two atoms is like the slit in the previous example. So there is a positive interference, and then you have a peak. Or you have a negative interference, and then you have a minimum. And of course, this is the fingerprint of any material. So any material cannot be hidden to the neutron tool because they have a pattern, a diffraction pattern, as is called, which represents that particular material. So since the discovery of neutron in early 30 by Chadwick, you can see that the big step is due to Fermi, who used the neutrons to start all the nuclear research with the chain reaction. But then, after that, and you see, early 60 was Schallenbrockhaus' use of neutrons, you can see that all the work community in a global collaboration has essentially developed, and is still doing that. The last operating source is the SNS, Palatial Neutron Source at Oak Ridge in the States, but China is going to build an equally important spallation source in a few years with in the collaboration with other sources. This is a global research. It cannot be done by a single country. This is, for example, the ISIS source, still the most intense neutron source in the world at Oxfordshire. And